Hey guys, George Sokol here. I'm going to show you guys how to use DX11 tessellation and displacement to make a pretty nifty icicle material in UDK. So let's take a look at the icicles on this chain here. What's really cool about this material is that you can basically use mesh paint to decide where you want the icicles to form. So you can see here that I'm kind of painting away the icicles, and then also I can paint them back and I can place them wherever I want. So let's get started. So the first thing we're going to do is make our height map for the displacement. So I've got Photoshop open already, and I'm going to go to File, New, and we're going to do 128 by 128 for the size. It doesn't need to be very large. So I'm starting out here with a black base, and basically what we're going to do is we're just going to add white to it to build up the height. So I'm going to use a brush with a lower opacity setting. And I'm going to start painting these circles in here. And basically these circles are going to be the base of our icicles. I'm going to add 4 on here so we can get a little bit of variation between them. And what you want to do is start making your circle shape smaller as the color gets closer to white, as it gets brighter. That way you kind of get this cone shape that we would expect to see from our icicles. Okay, so now what I'm going to do, I'm going to do a quick levels adjustment so I can make sure we're getting our full range here. Alright, there we go. And then I'm going to go ahead and apply a Gaussian blur so we can get rid of all of this stepping that's basically happening in between the different values, so it'll look smoother. Alright, and that is our height map. Alright, so I've got UDK loaded up now. I just have this kind of empty environment here with this mesh in the middle. I just made this really simple mesh here, so it's easy to tell what's going on with our material. Also, in my content browser, I've already loaded in my height map, so you're going to want to do the same. Since we're going to be using DX11 stuff, the tessellation and the displacement, you're going to want to make sure you're running in DX11 mode. So if you look up at the bar up here at the top, you will see that it says DX11. If yours says DX9, that means you're in DirectX 9, and you have to change that. You can go to File, Switch Renderer, and go to DirectX 11. And then UDK is going to restart, and then when it reloads, when it opens back up, you'll be in DirectX 11 mode. So go back in the content browser here, and we'll go ahead and start making our new material. Okay, so the first thing we're going to do is add a constant 3 in here. And I'm going to plug this into the diffuse, and we're going to give this a color. And then I'm going to go ahead and add my height map. So we're going to tackle the displacement first. The first thing you need to do is go into the material properties down here, and under D3D11, where it says D3D11 tessellation mode, we're going to have 3 options here. we have no tessellation, flat tessellation, and PN triangles. So flat tessellation will tessellate the mesh, but it will retain its shape. It's not going to change it. Whereas PN triangles will tessellate it and then smooth it. So flat tessellation ends up being a lot faster, and since we don't really need to smooth the mesh, we're just adding the extra geometry for displacement, we're going to select that. Okay, so the first thing we need to do is make a constant 2 and then plug that into our tessellation multiplier. So for the first number for the constant 2 here, that basically controls the tessellation factor for edges, and then the second one controls tessellation factor for the interior of the mesh. I'm just going to leave both of these at 2. And then now we're going to do the displacement part here. So I'm going to create a linear interpolate mode, or you can just hold down L and click, and our height map is going to plug into the alpha. And then we need to make 2 constant 3's, and then the top one up here, the one that we're going to plug into A, we're just going to leave this at 0, 0, 0, and then the one that we plug in the B slot, we're going to put a value of -50 into the blue. And then one more thing we need to do is add a texture coordinate node, and we're going to plug this into the UV slot for our height map. And then we're going to have this tile 15 times in U and V. I'm going to go ahead and clean this up here really quick. And we're going to go ahead and plug this into world displacement. And we will see what happens. Okay, so if you take a look at the mesh here, you can see that our displacement is clearly working. We have these icicle-like shapes protruding from the bottom of the mesh. Since by default displacement is happening in world space, we can rotate our mesh, but the direction of the displacement is always going to stay the same, which works out pretty nice for our icicles here, because that means we can have meshes in any orientation in our scene, and no matter what, the icicles are always going to face towards the ground, which is kind of what we want anyways. You'll notice that we kind of have this flickering going on the side of the mesh, and also if you look at the top of the mesh, you're going to see these holes punching through. What's actually happening here is, since our displacement is happening on our entire mesh right now, we're kind of getting these icicles kind of sticking through our mesh and coming into the inside of it. This is something we definitely don't want, and this is what we're going to address next. Okay, so for this part, I'm going to go ahead and disconnect our world displacement. It's actually going to be just a little bit easier to visualize what's going on if we just stick to colors. So I'm going to make another color here, and it's going to be another constant 3. And I'm going to give it kind of a bluish color. This is going to basically be representative of our icicles. And I'm going to plug in another linear interpolate node. Oops. And then we're going to plug the brown into the A slot and the blue into the B. And then when I plug that into the diffuse, we get an error here just because we don't have anything in the alpha yet. For the alpha, we're going to use something that's called up vector blending. In this situation, I guess technically it would be down vector blending, But up vector blending is a pretty common technique that's used for snow and dirt, things like that, where they basically only form on the parts of the mesh that are facing up, on the normals that are facing up. So if you'd imagine like a rock with snow on it, the sides and the bottom aren't going to have snow collect, but the flat parts that are facing up towards the sky, it's going to collect. We're pretty much doing that, only the opposite, where only the icicles are only going to form on the bottom of our mesh, but on the top it'll remain flat. So I'm going to put a couple constant 3s in here. For this first one, I'm going to put in 1 for the blue. And this is going to basically act as our normal direction for our mesh. And then for the second one, I'm going to put in -1 in the blue. And this is going to be our down vector. So the 3 colors, red, green, and blue, also work as X, Y, and Z. And having this -1 in the blue basically means we're saying down in the Z-axis. With the exception of world displacement and maybe world position offset, I'm not sure about that one. Everything else is going to take the X, Y, and Z values, and it's going to put them in tangent space by default. So while that's fine for our normal direction, we need to change that for our down vector. So we're going to use what's called a vector transform node. It's just called transform in the expressions list here. And we're going to connect that number into there. And if you look at the properties of this node, you'll see that it's bringing it in tangent space and outputting in world. So now basically we have the vector for the normal direction of our mesh, and then we have a vector that points straight at the ground. Now we need to compare these two. So what we're going to use now is a dot product. And I'm not going to go into too much detail about what a dot product does, but the important thing to take from it is it's going to take our 2 vector values here, and it's going to put out a scalar value. So the dot product is going to put out a value between -1 and 1, and the closer that these 2 vector values are to being the same angle, the closer the value is going to be to white. We don't need the -1 out of this, so we're going to just put a constant clamp on there. I'm going to go ahead and label this with a new comment. And we're going to take this and plug this into our alpha. Alright, so let's take a look here. I'm actually going to do this in unlit mode. So you can see that the bottom of our mesh has our blue color for our icicles, and the top and the sides do not. They're brown. So now if I were to rotate this object, you'll see that it'll start to change color based on what parts are facing towards the ground. So we can take a look real quick and see how that works with our displacement. So we'll go back into here, we'll make a new linear interpolate, plug our down vector blend into our alpha, then we'll take our displacement, put that in the B slot, and then once again we'll use this 0, 0, 0, which is no displacement, and we'll put that into A. And we'll stick that into world displacement, and we'll take a look. And there you go. The bottom of our mesh is displacing, and the top is not. Actually, it looks like we've got a bunch of holes in here now. That happens sometimes. Tessellation in UDK is not exactly perfect. It's kind of easy to get those holes. One thing you can do that kind of helps, if you go into your material properties, back under D3D11, right under tessellation mode, you'll see a checkbox for enable crack-free displacement. And we'll give that a shot and see if that helps. And it looks like for the most part it does. You've still got some holes in there, but mostly it's not so bad. Again, UDK does not handle this perfectly. Those kinds of things happen. We'll worry about that later. Alright, so that was pretty much the most complicated part of our material. Now we're going to set up our vertex painting. So I'm going to go over here and grab a vertex color node. And we'll drop it in here. And I'm going to disconnect our down vector blending from the alpha, and we'll plug in the red channel of the vertex color into that node. Actually, it looks like these colors are switched now, so I'm going to have to switch them. Okay. And then also going to put another lerp in here, and we're going to use the same color for our displacement. So we're going to put our displacement into A, and then no displacement, or 0, 0, 0, into B. And we'll plug that in the world displacement. Alright, and let's see what that did. Okay, so basically our mesh kind of looks like it did right at the beginning of the tutorial. It's just brown. The only difference is we can go into mesh paint mode now. Actually, I'm going to go into unlit mode to make this easier to see. And we can, having the red channel selected, we can go on here and paint on our mesh, and we can paint our icicles on. So like before, if we paint up on the top of the mesh, you'll see that we get our color from our ice, but we don't get our displacement. But if I close mesh paint mode here, if I go in here and rotate the mesh, you'll see that as that side starts to face towards the ground, it'll start to displace. So now we can have a mesh in any orientation we want, and we can put it in our scene, and we can paint our icicles on there, and they'll always face down. So that's pretty much the main functionality for this material. Okay, so now that the basic functionality is done, I'm going to go ahead and add my own personal flair to the material. So I'm going to speed through this part. Alright, so I'm pretty much finished here. Basically, I just added a cube map reflection and emissive to the ice, and then I got a diffuse spec map and normal map for the base mesh. So let's take a look at our final result. Alright, so here's our end result. Just like with the chains and that I showed you in the beginning, I can go in here and decide where I want my icicles to be. So I can completely remove them if I want. Or I can paint them back in wherever I want. And I can rotate this in any orientation I want. Alright, and that concludes our tutorial on making a tessellated and displaced icicle material in UDK. Once again, I'm George Sokol. Thanks for watching.